Then we have, these are all the additive laws, and they have to be very carefully learned, and they have to be very carefully written and memorized, because I believe that they may come in your objective type questions, like they may ask in your MCQ part, or they may ask in your objective short answers, or they may ask in your sometimes they may ask in your viva voce, or maybe as a very long question of let's say 10 to 11 marks or 12 marks, or whatever the marking is. But I believe if they say that, let's say just, and I think these kind of questions are a very great hit to actually cover your mathematics with a great score, because I believe that and I think that all of these numbers, or all of these laws, like all of these properties, they are very important to gain extra strength. And I think that multiplication laws are like Cloyer law of multiplication for all. Every single property that we have studied for additive laws or addition laws, it can also be stated as addition laws, but additive identity or additive inverse is actually different. You just have to state it at addition laws, not additive laws. And because addition is just a binary operation of mathematics by which we actually add two numbers, like 0 plus 1 is equals to 1, or 1 plus 2 is equals to 3. Then we have multiplication laws. They are just in line or just the similar ways as that of the addition laws, but multiplication laws are like you just are multiplying two numbers, like 0 times 1 is equals to 0, and then 2 times 0 is equals to also 0, but 1 times 2 is equals to 2, or 5 2s are 10. You can just, and I think as a student of mathematics in class 11, because this is the maths that is actually applicable on 11 class and above, some things may repeat in above classes as well, so you just have to learn everything by heart and practice everything by heart at the very start of your you may say that degree and or subject of mathematics. Because if you learn something very by heart at the very start, then you will actually be able to actually learn or grasp, or you may say that understand deeply mathematics in the future or upcoming life or subjects or degrees. Because it is like you have just learned ABC, right? And now you can make sentences. You have learned the very basics, and now you are able to make something great out of it. This is just the beauty of a subject, of a very basic, this is the very basic subject, okay? And multiplication laws are just similar. You just have to use the symbol of multiplication, which is actually a dot or a cross. And multiply means you just have to multiply, upgrade. Like Cloyer law of multiplication will be for all AB belongs to real numbers, A dot B belongs to R. AB is usually written as AB, because if it is written as AB without a symbol of dot or cross, then it actually also means that AB is actually, like you may say, what should I say? AB is actually the multiplicative numbers, like you are just writing two numbers and they can be multiplied. Then we have associative law for multiplication. Associative means you just putting brackets and putting the numbers inside of it. Like for all ABC belongs to R means real numbers, comma A bracket B C comma actually A bracket B C bracket close is equals to, you're just replacing the brackets, and it is just simple. You're just using the concept of bracket so that your more numbers can be accommodated or written side by side. Then we have multiplicative identity. For all A belongs to R, that there exists 1 belongs to R such that A dot 1 is equals to 1 dot A is equals to A. A can be any random number, okay? And you can just say that multiplicative identity or additive identities are actually written with the concept of one number. Like actually one number means that it can be any not any number. It for additive identity it is number 0, and for multiplicative identity it is the number 1. And why for addition the number 0 is used as an identity and why number 1 is used for multiplicative identity? Because both of these numbers are actually neutral. When we talk about in addition, it is 0, and when we talk about 1 in the case of multiplication, and it is considered to be as a neutral number. It can be multiplied with anything. That will not change the identity means the description or the personality, or you may say the reality of a number. Now, one is called the multiplicative identity of real numbers, okay? Because if you just multiply it with any number, even 1000 or 6000 or 6 lakh or 6 crore, it is not going to change the reality of that number. And if you add 0 in any number, it is not going to change the reality of that number. Then multiplicative inverse will mean that for all a bracket not equals to 0 belongs to real numbers, there exists a raised to power minus 1 belongs to real numbers such that a dot a raised to power minus 1 is equals to a raised to power minus 1 dot a is equals to 1 belongs to not actually this is not the symbol of belongs to, bracket started a raised to power minus 1 is also written as 1 over a. Now you just don't have to confuse stuff here. I believe inverse means the reverse of anything, right? Like for example, if you say that inverse is actually like a raised to power minus 1 is equals to 1 over a, then I believe that I think 1 over a is actually, it's like a has the power of positive 1 when there is nothing written on it, and if it is taken on the upward sides, then it is written to be as a raised to power minus 1. And then we have commutative law of multiplication. Commutative law of multiplication is for all a b belongs to real numbers, comma a b is equals to b a. And like as we have the commutative law of addition, then we have the commutative law of multiplication in a way that a b belongs to real numbers and a b is equal to b a. Because you know that a b are just two numbers and b a, these are two numbers that are actually equal to each other, and you may say that like you are just using two numbers and you are adding them, and that will be called as the commutative law of addition. And then when you are just multiplying two numbers, let's say 1 times 1, it is equals to 1 times 1. If you multiply 2 by 4, that is 8, it will also be equal to 4 by 2. It means if you just mix and match both numbers and write them side by side and change their positions on the other side and multiply them and get the answer, that will also be equal to that same number. That is why the equality sign is written in the middle, because otherwise if 1 is equals to 1, then it is true. Then if 1 is not equal to 2, because 1 is not equal to 2, equal to signs means equality. Like if you have 10 mangoes on the right hand side, then you have 10 mangoes on the left hand side, or 10 mangoes on the left hand side and 10 mangoes on the right hand side, same thing, okay? That just means the same thing. So we were actually discussing these properties, and I think that as part of a teacher or on my part, I will suggest that you should all deeply memorize the properties of addition and multiplication. Why? Because I think that sometimes a teacher might ask that maybe a student is that intelligent enough to know, or just smart enough, or maybe just a student knows. That is also okay. You do not have to be super intelligent to understand everything, but I believe that you just have to try to enjoy life and enjoy the knowledge that has been written in the books, because this is what life is all about. You just have to be so focused in your book or books or knowledge that you just forget about everything. This is not about making yourself a part of that fantasy land, but I believe that some things are really important, that they just have to be understood in a great way. And I think that it's okay if you just learn new stuff and practice it by writing it. And you just have to learn things by heart by writing them down frequently means you just have to write stuff in a way that actually makes sense to you, and you just don't pass it on, and you just have to make sure, like, you can just repeat a lecture, understand it again and again, listen to a lecture again and again to actually understand something.